single phase transformer. Okay, with respect to that single phase transformer, we'll have a glance, then you can proceed for the other. Okay, with respect to the single phase transformer, it is the static electrical machine. Okay, which will transfer the electrical energy or the power. Okay, from one circuit to another circuit without changing frequency. Okay, that itself is called as transformer. Okay, this will provided with respect to the AC power supply. That power supply will be supplied to that of connected load center. Okay, especially which it is to be get connected magnetically, but not from electrically. Okay, because of the Faraday's law. Then according to that only, which will transfer the electrical energy from one circuit to another circuit. Okay, then the basic function of transformer is to increase or decrease the voltage. Okay, that is called as step up and step down. Then without changing also we can maintain. Okay, that itself is called as 1:1 transformer. Okay, why it is called as a static machine, which is not having any moving part in it. Then working principle of the transformer, which works on the principle of mutual induction. Okay, with respect to the two winding. If it is a single winding, self-induction. Okay, which it is having a primary, then which it is having a secondary. Whenever the power supply is given to the primary winding, then alternating current will flow through the primary winding, which will produces the alternating flux. That alternating flux will be linked with respect to the secondary. Then flux linking with respect to the conductor changes with respect to the time, then which will causes the induced EMF in the secondary. Okay, then which it is to be get connected to that of load center. Okay, that itself is what? The transfer of electrical energy from one circuit to another circuit without changing the frequency. Okay, this principle is itself is called mutual induction. Then with respect to the construction point of view, the majorly in case of transformer, two parts, one is winding, then another one is core. Okay, that also be called as magnetic core. Okay, the primary winding is nothing but winding which is get connected to the supply. Secondary winding is nothing but the winding which is get connected to the load. Then windings are made up of copper. Whatever the windings which are to be there, those are to be made up of by copper itself. Whenever the power supply is given to the primary winding, which will produces the magnetic flux. Okay, this line of flux will be cut with respect to the secondary, will causes the induced EMF. Then what is the magnetic core? Okay, which will provide the mechanical support for the winding for the primary and secondary, and also which will provide the path for the flux. Okay, that is the function of magnetic core. Okay, core is made up of the silicon iron with a high permeability itself in order to carry the more magnetic flux in it. Okay, limb is nothing but these vertical parts of the core are called as limb. Okay, that itself will carry the winding. Is there any disturbance? Is my audio is clear? Anyone confirm? Screen is visible now?
Yes, sir.
Okay, thank you. This is with respect to the what? Construction of the transformer. Then working principle. Okay, here the single phase transformer will be works on the principle of mutual induction. Okay, those are connected magnetically with each other. Then whenever the primary winding will be get supplied with respect to the alternating voltage, which will causes the alternating current to flow. Because of that reason, the alternating flux are produced. Then this alternating flux will be linked with respect to the secondary winding, then which will causes the induced EMF. Okay, that principle is itself is called what? Mutual induction. Keep that is in mind. Don't forget. Then EMF equation of the transformer. Okay, N1 is number of turns in primary, N2 is number of turns in secondary, E1 is EMF induced in primary winding, E2 is EMF induced in secondary winding. As per the Faraday's first law, that is the flux linking with respect to the conductor will causes the induced EMF. But what is its magnitude? That can be defined by the second law. The magnitude of the induced EMF is directly proportional to that of rate of change of flux link with respect to that particular conductor. But here there will be a n number of conductors. Because of that reason, E1 is equal to minus N1 into d pi by dt. Why it is negative? Because we are considering EMF induced in the same coil, not in other coil. So that according to the Lenz's law, cause produced by the winding which itself is opposite to that of applied voltage. So that the negative sign will be taken. Then whatever the voltage is applied is alternating in nature, which will causes the alternating flux. That is pi is equal to pi m into sine of omega t. Substitute that pi in d pi by dt. Okay, pi m is the constant, so that I am taking that outside. Then differentiation of sine omega t is what? Cos of omega t into omega. Okay, so that omega is equal to 2 pi f n1 pi m into cos of omega. Then cos of omega, that is a negative of cos of omega, will be represented by sine of omega t minus 90. Then whenever you are comparing, that is with respect to the E1 is equal to Em into sine of omega t minus 90. Okay, then we are comparing, that is with respect to the same Em1 is equal to 2 pi f into n1 into pi m. Okay, but we want RMS value of the voltage. E1 is equal to Em divided by pi, which is equal to 0.707 into 2 pi f into n1 into pi m. Then this itself is called as EMF equation of the transformer. E1 equal to 4.44 f into pi m into n1. This is for primary. For the secondary is what? E2 equal to 4.44 f into pi m into n2. One is for primary, two is for secondary. Keep this is in mind. Then next is K. K is the transformation ratio. Okay, this is the what? The ratio of the secondary voltage to the primary voltage V2 by V1. Then the ratio of the RMS value of the induced EMF in secondary to that of primary, that is E2 by E1. The number of turns in secondary to the number of turns in primary. Then the ratio of the primary current to that of secondary current. Okay, this itself is called as the transformation ratio. Okay, all these things are important for the problem point of view. Keep that is in mind. Don't forget it all. Then types of transformer. Based on construction, there will be a core type, then there will be a shell type. Based on the voltage level, step up, step down, then auto transformer, then 1:1 transformer. Then based on the application, primary transformer, distribution transformer. Based on the measuring application, current transformer and potential transformer. Okay, but among these you concentrate on shell type and core type as per your syllabus. Okay, core type transformer is one. Okay, in which the whatever the windings will be there will cover the core, entire core. Okay, means the winding will encircle core itself. That type of transformer is itself is called as core type of transformer. Okay, those are having a laminations. Okay, those laminations are connected together to form the core. Okay, then that core will be get winded with respect to the winding. Okay, this is the line diagram. Okay, this is with respect to the representation of the transformer. Okay, the whatever the limb of transformer is there will be get covered by the winding. Okay, at both side. Okay, this is with respect to the what? Core type of transformer. What happens in case of core type transformer? Winding will cover the complete core. Most visible part in case of core transformer is winding. So that this itself is called as core type of transformer. Keep that is in mind. Then with respect to the shell type transformer. Okay, instead of winding, core itself will cover the winding itself. Okay, here the center limb will be there. The center limb will carry the winding, the primary as well as the secondary. Then either side of the windings will be get covered by the core. Okay, this type of transformer itself is called as shell type of transformer. Okay, whatever in our laboratory we are having is itself is shell type of transformer. But core type of transformer is most commonly not using it. because there will be a more leakage flux in it. Okay, if the leakage flux is more, then obviously whatever the voltage magnitude will be there will be get reduces. Okay, this is with respect to the what? The cell type and the core type of transformer. Then in previous class I have discussed about the losses. There will be majorly two parts. One is magnetic core, then another one is winding. The whatever the losses which are to be caused by the core is itself is called as core losses. The whatever the losses which are to be caused by the winding are itself is called as copper losses. Okay, then with respect to the core loss, because core is made up of by iron, so that also be called as a iron losses. Then whatever the flux which are to be get produced will be proportional to that of the voltage, then that will be remains constant itself. Then obviously that will not be changed. Then iron loss or the core loss are to be called as constant losses. Okay, these losses are to be caused by the magnetization and the demagnetization of the winding, whatever which is to be producing the flux, which is linked with respect to the core or the iron. Okay, that's why it is called as the core loss or the iron loss. Then in case of core losses, again there will be two losses. Okay, one is hysteresis loss, then another one is eddy current loss. One is hysteresis loss, another one is eddy current loss. You might be see here with respect to the transformer. This is core. This core is made up of by what? Anybody? Which material will be used for core? No one listening.
Silicon.
Silicon steel, not silicon. Okay, silicon steel. Then obviously what happens? That silicon steel is also a conductor. Is this flux is also be linked to respect to that conductor? Yes. Obviously the flux linking with respect to this conductor is changes will cause a current to flow through this core. Okay, that current is itself is called as eddy current. Okay, that losses are called as eddy current losses. Okay, to reduce that eddy current losses, the cores are get laminated to each other. Okay, then hysteresis loss. There will be a loading and unloading of the transformer will be taking place. Because of that reason, the magnet of the flux would be get changes. Then that losses are itself is called as hysteresis losses. Okay, remember the formula. This is more than enough for examination point of view. Okay, these are the what? The losses which are to be present in the transformer. Then with respect to the copper loss, okay, there will be a primary winding, there will be secondary winding. The losses which are to be occurred by the primary winding will be represented by I1 square into R1. Then secondary winding will be represented by I2 square into R2. Current magnitude will be get changes with respect to the load variation. That's why these losses are also be called as variable losses. Because as the current changes, then obviously those losses are to be also be changed. Any doubt?